to start with the future of nuclear energy, and I read Dr. Mark Eaton's, the director of Idaho National Lab, to give us his presentation and also some comments.
Thanks.
Mark.
Morning.
Morning.
How are y'all doing? Good. So full disclosure, I hate to tell you this, but I got a bachelor's from Auburn University, War Eagle. And had to get that out of the way. So a little bit more about me. I've been the lab director at Idaho National Laboratory for a little over 2 years. I've spent most of my professional career in the labs, started at Los Alamos National Lab, spent a big chunk of time at Argonne National Laboratory in the Chicago area, and then I've been fortunate enough to be in Idaho for, like I said, a little over 2 years. My background's in geochemistry, both my undergraduate and graduate degrees. And why does a geochemist end up in this world? My path was through Yucca Mountain. So we can talk about that if you'd like, maybe during the questions. Not sure I have answers, but we can certainly discuss it. But that's my journey. I want to also, on a personal note, Ray mentioned he knows some of us. I consider Ray a very close friend and colleague. If you haven't had the chance to meet Ray Rothrock, meet Ray Rothrock. Take the opportunity, because if you want to get excited about the future and what the potential is, he's the kind of guy who will make you feel that excitement. So I emailed him last night. I'm going to be seeing him actually next Tuesday in Washington for another topic. So I'm looking forward to seeing him. Really appreciate the opportunity to be here as part of his endowed lecture series. So I thought what I would do is take the bold move of actually talking about the future of nuclear energy. But since I'm first, I sort of assumed I was first. So I'm going to take a big picture view and then let these very capable gentlemen talk about the specifics. Does that sound okay to you? So I'm going to sort of do a broad brush. Get a little bit into policy. National labs don't play in policy, but we're a part of what has to inform policy, so I'll get a little bit into that. Like I said, the other panelists are going to step up and be able to talk with much more authority on many aspects of this as well. So what I would start with is that the future of nuclear energy is not just a domestic challenge, it's a global challenge. As you are well aware, we're seeing expansion of nuclear energy across the globe. Perhaps not in the US. We're, of course, going through some unique and acute struggles with the existing fleet, and I know Jeff and Tim will probably touch on that quite a bit. But there's an opportunity through the government role and the private sector role in the United States, in a global collaboration sense, to reestablish our leadership, both in the industrial sector as well as the research sector. Arguably, the national labs and the university system in the United States is still best in class, second to none. How do we go about taking advantage of that innovation and working with industry and the government to actually leapfrog and get us back into maintain our leadership across the world? We may not build a lot of new nuclear plants in the near term here in the United States, but there's opportunities for U.S. technologies, and we think about that a lot as U.S. national labs, how those can actually be a part of what is a global expansion. As Hasim mentioned in his intro, Ray and others are doing a lot of interesting investments in the reactor space, and so we have a very capable fleet of light water reactors that are operating today. And we've got light water SMR, small modular reactors on the horizon, but there's also an interesting ecosystem developing in the non-light water reactor Generation 4 space. Where you're seeing a lot of private sector capital, venture capital, high net worth individuals coming into the game. And so it's really created this interesting, even as 5, 6, 7 years ago, you didn't see that. So a lot of this is new. For the early career young people in the audience, I think you're entering into this space in a very interesting time. And I think there's a lot of different opportunities that you could pursue. So I think there's challenges, but with every challenge, as I always say, there's ample opportunities. And so as we're remarking today, make us talk about the opportunities, not just about the challenges. There, of course, are challenges. These are all considerations that has to go into thinking about how do we enable a nuclear energy future. How do we make the systems economic, cost competitive? How do we continue to push the envelope on safety? The systems that we operate today are safe, very safe, but how do we continue to push to make things simpler, safer, and more economic? Always with the mind of how do we protect in terms of a non-proliferation perspective and make sure that the systems are secure. A big part of the conversation in the last administration, a big part of the value proposition for nuclear energy that was emerging was a lot about how do we use nuclear energy as an important part of the energy system so that we're mitigating climate change. That's still very important, but there's also been a very, very strong, particularly with this administration, emerging narrative that we need to talk about how it's important for our national security. Energy security, national security, maintaining global leadership are an important part of why you need a strong civil nuclear sector. Then finally, waste management. In general, these are not technical challenges. You need to do great science and engineering to be able to figure out how to deal with spent nuclear fuel and nuclear waste. But in the end, those are solvable problems. A lot of this is, quite frankly, socio-political challenges that have to be addressed to get to the next step. But it's all about making sure that the public, the other stakeholders continue to think that this is a safe, affordable, resilient, clean technology for the future. So quickly, and then again, I don't want to steal thunder, but I'm going to sort of walk through sector by sector or part by part of the nuclear energy space. We have the existing fleet. The color code here is just the NRC region, the Nuclear Regulatory Commission region offices. I took this from the US NRC's website. Just to give you a sense that we currently have 99 operating. You're probably familiar with the stresses that the existing fleet is experiencing, and I'm just going to leave that at that. And I know Tim's certainly going to talk about that at some length. I do think there's some positive things going on in Washington right now, particularly with Secretary, your former governor, now Secretary Perry, is driving the right conversation about how does nuclear not only produce clean electricity, but also be a part of what should be a reliable and resilient energy system. So there's really good policy conversations beginning there. We'll see where they end, but I like the fact that that the Secretary's leadership is providing that opportunity to have those conversations. You're probably also aware that we have new builds ongoing or in design and licensing process. The AP1000s being built across the globe, the Westinghouse design. You're also probably familiar that we've had some challenges in South Carolina. The 2 units there have been put on hold. Effectively, the utility there has basically decided not to complete construction. We're still waiting to see what Southern Company will do with the two new units at Vogtle in Georgia. There are indications that they're going to be moving ahead. They're starting to get certain indications from the government and their investors and the partner utilities. So I'm hopeful that those will actually move ahead. The interesting wave in the US and globally is going to small modular units. Of course, modularity is something that the nuclear Navy's been practicing from its inception. But taking that and thinking about small modular reactors, both light water cooled as well as non-light water cooled. NuScale Power is a US-based company that's really one of the first movers on this. Talking about building first-of-a-kind units, we hope actually on our site in Idaho, and also talking to Tennessee Valley Authority about possibly building in the Oak Ridge Reservation area as well. But these are examples of sort of evolutionary designs that are opportunities for us as the United States to have world-class designs, build them not only domestically but globally. And so the focus, certainly of the national laboratories, is to do everything we can to help them be successful. What about advanced reactors? So many of you are probably familiar with Generation 4 systems. And this is really in the research development and hopefully soon demonstration phase. The Gen 4 systems range from molten salt cooled systems to liquid metal cooled systems, say lead cooled, sodium cooled, as well as gas systems, both fast systems as well as thermal. So, and some of those can actually go to quite high temperatures. So a big part of when you think about the advanced reactor space is not only how do you be a part of a clean electricity system, but how do you also produce, say, high temperature heat and other products so that you can actually penetrate the manufacturing sector, the industrial sector, as well as the transportation sector. The future business case for nuclear has to think about things beyond electricity in order to become part of an economic energy system going forward. So there's a lot of research going on, labs, universities, in partnership. This is a lot where you're starting to see the startup companies coming up across the Generation 4 concepts. We'll see there's better than 50, if you count them, so-called companies that have come up that are thinking about both fission systems as well as some companies thinking about fusion systems. Will all of those be successful? No, never. But what I like about it, it drives a really interesting innovation, entrepreneurial kind of discussion in nuclear that you haven't seen, arguably. I haven't seen it, certainly in my career, in my time in the laboratories. So great opportunity there. Kelly will talk more about the research part of that, so I'll leave that to him. The fuel cycle, we're now starting to get back to a broader fuel cycle conversation with the Trump administration, talking about how do we think about enrichment capability and reestablishing enrichment capability in the United States, all the way out to what do you do about spent fuel that's sitting on reactor sites and DOE sites across. Do you go to interim storage? Y'all in Texas are familiar with, of course, Andrews County is one of the places that would likely be, we hope, likely be one of the places for interim storage. But ultimately, according to U.S. policy, you've got to get back to licensing, developing, constructing, and operating the geologic repository. That's Yucca Mountain, according to the law of the land. If it's not Yucca Mountain, where is it? But we need to get back on the path of developing those options for the future. If you don't solve this problem of how to manage spent nuclear fuel, it makes the future of nuclear conversation very complex, I would say. So I think if we can get this moving, even if it's just moving fuel to interim storage, I would argue that would really help to further the narrative. Then finally, more in the lab and university space, and is one of the things that we've realized particularly over the past few years, is that if we're serious, there's an urgency to this, right? If you're going to really impact being able to mitigate climate change, if you're really going to make sure that the United States stays in the leadership position, you've really got to think about how the labs and the universities work with industry in a really different way. How do you accelerate innovation in the nuclear space? Because nuclear systems are large, complex, go through a licensing process that's necessary, that tends to lead to very long development, demonstration and deployment timelines. So how do you think about accelerating innovation? How do you take advantage of people in this room, the facilities at Texas A&M, at the laboratories? How do you make sure that the United States has all the facilities available? We have ample test reactor facilities in the United States, arguably, to support the nuclear navy as well as industry and research in the thermal spectrum, but we lack fast neutrons in this country. So one of the things that we're thinking a lot about with the labs and universities, including folks here, is there a future fast test reactor in the United States that needs to be constructed? So that's exciting for us. But how do you, again, just emphasizing, how do you accelerate innovation in this space? Not actually straightforward. So how do you think about that? And then I'm going to skip over that because I think we're going to touch it. But I'm happy to leave these slides. There is a large set of things, if you map the challenges of waste management, non-proliferation, security, economics, and safety, there's a large set of policy things that have to happen that are starting to emerge, starting to happen, and I think we're going to hear more about that from the panelists. And I think that would be a good thing maybe we could talk about in discussion as well. So hopefully that's a good introduction. Really appreciate you being here. It's great to be talking to a group with so many young people. Great to see so many people thinking about nuclear engineering and the nuclear space for their future. We're hiring, so if you're interested, come see Kelly or I. And internships are ample, so please come to INL. Okay, thanks.